Welcome to the course 3D Printing. Today we are going to learn methods and technologies used in 3D printing. 3D printers are available with different technologies and do not use the same technology to realize their object for various applications. Let us begin with the technologies of 3D printing. Before start, let us discuss its role. There are several ways to realize object of 3D printer and are different mainly in the ways layers are building to create the final object. Different methods are used for rapid prototyping and rapid manufacturing, and it is for melting or softening material to produce the layers. Selective layer sintering and fused deposition modeling are the most common technologies using this way of printing. Another method of printing is to lay liquid material that are cured with different technologies. The most common technology using this method is also called as stereolithography. Have a look at these common methods which are listed below and are readily accessible to small manufacturer. Let us discuss the selective laser sintering technology, which is an additive manufacturing technique that uses a laser as a power source to sinter powder material. It aims the laser automatically at points in space defined by the 3D model, binding the material together to create a solid structure. Some SLS machines use single component powder, such as direct metal laser sintering. Powders are commonly produced by ball milling. However, most SLS machines use two component powders, typically either coated powder or the powder mixture. Look at this picture which explains the method. The laser selectively fuses the powder material by scanning the cross-section generated by 3D modeling program on the surface of a powder bed. After each cross-section is scanned, the powder bed is lowered by one layer thickness. Then a new layer of material is applied on top and the process is repeated until the object is completed. Another technology used in fused deposition modeling. Fused deposition modeling (FDM) is a layer additive manufacturing process that uses production grade thermoplastic material to produce both prototype and end use parts. Solid Concept offers a number of thermoplastic FDM materials that can be used for direct digital manufacturing. The FDM technology works using a plastic filament or metal wire, which is unwound from a coil and supplies material to an extrusion nozzle, which can be turned the flow on and off. The nozzle is heated to melt the material and can be moved in both horizontal and vertical directions by a numerically controlled mechanism. It is directly controlled by a computer-aided manufacturing, that is CAM software package. FDM works on an additive principle by laying down material in layers. A plastic filament or metal wire is unwound from a coil and supplies material to an extrusion nozzle, which can turn the flow on and off. The model or part produced by extruding small beds of thermoplastic material to form layers as the material hardness immediately after extrusion from the nozzle. Stepper motor or servo motors are typically employed to move the extrusion head. Now let us discuss stereolithography apparatus method. Stereolithography is one of the several methods used for creating 3D printed objects. It is the process by which a unique design 3D printing machine called a stereolithograph apparatus convert liquid plastic into solid objects. Stereolithography builds plastic part or object a layer at the time by tracing a laser beam on the surface of vat of liquid photopolymer. This class of material originally develops for the printing and packaging industries. Whenever the laser beams strike the surface of the liquid, one layer is completely traced. It's lower a small distance into the vat and a second layer is traced right on the top of the first. The self-adhesive property of material causes the layer to bond to one another and eventually form a complete three-dimensional object after many such layers are formed. Some objects have overhangs or undercuts which must be supported during the fabrication process by support structures. These are both manually or automatically designed and fabricated right along with the object. Upon completion of the fabrication process, the object is elevated from the vat and the supports are cut off. Another method is direct metal laser sintering. Direct metal laser sintering is an additive manufacturing technique that uses a laser as the power source to sinter powder material. It aims the laser automatically at point in space defined by 3D model, binding the material together to create a solid structure. It enables the manufacturer of geometrically complicated metallic parts over conventional manufacturing processes simply cannot replicate. DLMS uses a metal powder and SLS typically uses a plastic powder. The powder is spread across the working platform. A laser traces the outline of each part being printed. Fusing DLMS or melting SLS the powder to the layer below it. The platform is lowered, a new layer of material is spread across the platform, and the process repeated until the print job is complete. DLMS technology has traditionally only been available for printing non-precious metal. Post-printing processing requires cutting off the support material. This is for today. See you in the next session.